Welcome to True Projects. In this video, we are going to explain about the project which is ML powered handwriting analysis for early detection of Alzheimer's disease. Before getting into the execution, first let's understand what is the project about. So now we'll be detecting Alzheimer's disease, right? So what is this disease? It's a brain disorder where nerve cells slowly start to die off. And because of that, people begin to lose their memory and ability to think. It usually starts small, like forgetting recent events or conversations, but over time it gets worse. Eventually, it affects basic tasks like speaking or even writing properly. Sadly, there is no cure right now, and the treatments we have only help to slow it down a bit. Now, Alzheimer's is actually the most common cause of dementia, making up around 60 to 70% of the cases. Globally, over 55 million people are living with dementia, and most of them are in low and middle income countries. And the hardest part is not just the person with the disease who suffers, but also the families and caregivers carry a huge part of the burden. Caring for someone with Alzheimer's can take up hours every day, and it really adds up, costing over $1.3 trillion a year worldwide. So the tricky thing is early signs like changes in handwriting and motor skills. So these also get changed. They often go unnoticed, which makes it harder to catch the disease early. That's why finding better ways to detect it sooner is so important. So this project it looks at the link between brain function and the motor skills. So it looks up at cognitive and motor functions. Cognitive are nothing but it's a kind of brain function and the motor skills, focusing on handwriting. So here we're focusing on handwriting to detect the dementia, to detect the Alzheimer's disease. So we know that as the conditions of Alzheimer's disease progress, they can affect how a person writes. So when a person is diseased with the Alzheimer's, it also affects their handwriting. Through that, we can detect whether a person has the Alzheimer or not. So what are we doing is exploring handwriting analysis as an easy and non-invasive way to track these changes instead of relying on cognitive tests. So we had some traditional cognitive tests, so which can be lengthy and may miss subtle motor changes. We want to use machine learning to analyze handwriting analysis. So in this project, we'll be using some machine learning models to analyze the handwriting. For instance, small changes like shaky lines or inconsistent pressure could indicate early signs of decline. So, by developing a system that uses a common graphic tablets to assess handwriting, we hope to create a reliable method for early detection, making it easier for doctors to spot issues before they become serious. So, to tackle the problem of catching Alzheimer's disease early, we are developing a handwriting analysis using some ensemble based machine learning models. So the idea is to look at how someone's fine motor skills are affected by analyzing their handwriting samples from the dataset called Darwin dataset. So this dataset helps us to identify the subtle changes that regular tests often overlook. So here we are using stacking ensemble based model. So this model it combines multiple individual models to make the final prediction. So by integrating multiple classifiers, we can improve the accuracy of the system. Essentially, we are creating a more robust tool that can help to detect early signs of motor control issues. And in this project, we are using some feature selection techniques that is ANOVA and RFE. RFE is nothing but recursive feature elimination. So to focus on the most important data for the models. This helps us to improve the efficiency and accuracy. And to evaluate the model, we look at several key metrics, including accuracy, sensitivity, specificity, F1 score, Matthews, correlation coefficient, Cohen kappa, and AUC ROC curves. So, furthermore, as an extension to further improve the performance in this project, we are using other ensemble maze model that is voting classifier, which will combine bagging with random forest and decision tree. So this helps us to create a more reliable and accurate final prediction model. So we are looking the other ensemble technique to boost our performance even further. And this extension model voting classifier, it has achieved highest accuracy when it is combined with the ANOVA feature selection technique. So this model we have deployed it in the front end. On top of that, we have developed front end using Flask framework. So here we have developed front end using Flask framework. This will allow users to test the system with the users and also incorporate user authentication to ensure secure and access and make it user friendly. So coming to the implementation of the project, here first we begin with the importing required packages and then we explore the Darwin dataset, followed by we do some data processing like cleaning and removing unwanted columns. And then we visualize the data and then we convert categorical variables into numerical variables using this label encoding. And then we append all the features to X and target variable to Y column. And then we select the important features using recursive feature elimination and the ANOVA technique. Then we split the data into two sets. One is training and the other one is testing set. So we use training for training the models and evaluating for testing set for evaluating the models. After we split the data set, then we build all the models with the two feature selection techniques, that is with the RFE CV and the ANOVA. So each model is built with the feature selected of ANOVA and with the data feature selected using RFE CV. And then we compare all the trained models using this error metrics, that is accuracy, precision, recall, and FN score, AUC, Cohen Cup, and MCC. Then we compare them using graphs. Then we have developed front end using Flask framework, where we have created registration, login, and setup for secure authentication purpose. And then users, they will give input values in the front end. Those input values will be pre-processed at the back end, and that input will be fit with the trained model to give the predictions. Finally, outcome will be displayed to front end. And here we have used some of the algorithms. So we have used random forest, logistic regression, linear discriminant analysis, Gaussian naive Bayes, extra tree, XGBoost, KNN, SVM, MLP, decision tree, stacking classifier, and extension voting classifier. So this is the proposed model and this is the extension model. So this extension model with the ANOVA feature selection technique has achieved the highest accuracy. So we have used it for deploying in the front end to predict the Alzheimer's disease. And all these models are employed for comparison purpose to see how well the proposed and extension models are performing. Moving on, to implement this project, we need some basic requirements that are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So let's open the code folder. So these are the source code files in the code folder of the project. Now let's understand how will they be used in the project. So coming to the Darwin folder, in this folder we have the dataset that is used in the project, in which we have all the handwriting related variables. So here we have all different many independent variables which impact the Alzheimer's disease. So using these variables will be detecting the Alzheimer's disease. So if you observe, we have so many variables, right? So from these variables, we'll be selecting the important ones. That means we'll be selecting the features using ANOVA and RFE CV. So now let's close this, get back. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. And in this templates folder, it contains HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is the model file which contain the algorithm information, and this will be loaded into the project code during runtime. And here we have two notebook files. One is ANOVA and the other one is RFECV. So these are the Jupyter notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. So in this ANOVA Jupyter notebook file, we have the code in which data will be pre-processed using ANOVA and all the models will be built on the data set. I mean, all the models will be built on the features extracted from the ANOVA. And coming to this RFECV, here we'll be having the code where the data's features, I mean, features from the data will be extracted, selected using recursive feature elimination technique. And all the models will be trained on the feature selected using RFECV. So here in this ANOVA processed file, here we'll be having the data set after extracting the features from using ANOVA. So these are the extracted features after using ANOVA technique. So these are the important features selected. And here we have the target variable where we'll be having two different classes. Now let's close this. And here in this, we'll be having the data set after extracting the features using RFECV. So these are the features which are extracted using RFECV. So now let's close it. And coming to the sample file, in this we'll be having test cases that we'll be using in the front end to test the Alzheimer's disease. That means to detect the Alzheimer's disease in the front end. So now close this. And this is the sign up file, which is a database file which is used for storing the user information. Now we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we have to open the Anaconda prompt. So now using the command cd followed by the space, paste the copied path and now click on enter. So this will change current directory to the code folder's path. Now we have to compile app.py file. So give the command python space app.py and now click on enter. So this command, it will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So now we have to copy this local link provided by the Flask framework and paste it into any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project which is displayed in the browser and this is developed using Flask framework. Now let's sign up. So click on sign up and give all the registration details if you are registering newly. I have already registered, so I'll directly sign in. So click on sign in, give the username and the password and click on login. We have logged in successfully and we are redirected to prediction page. So here you can see some parameters, right? So we need to give input to these parameters. So based on the given input, we'll be getting prediction. So all these parameters are related to the handwriting. So now let's understand what these parameters are. So the first parameter, total time, it is the overall duration taken for the task or the experiment from start to finish. So here the number 9, it means that it is for the ninth task. So coming to GMRT on paper, it is the mean rate of movement while writing or drawing on the paper. So here it is the 10th experiment. So moving on, mean speed on the paper. It is the average speed of writing or drawing on the paper during task. The next one we have paper time. Paper time, it is the time specifically spent on writing or drawing on the paper. Next we have is mean GMRT. It is the average gross motor rate of the participant during the task. Here we have total time. It is the same as the above total time, but it is for the ninth task and here it is for the 15th task. Coming to airtime, it is a duration spent with the writing instrument in the air, not touching the paper, and it is for the 17th task. Coming to mean jerk in the air, it is the average rate of change in the movement while writing the instrument in the air, and it is for the 17th task. So here we have total time for the 17th task, and the next we have a time, it is for the 19th task. Next we have is max x extension. It is the maximum horizontal extension or the distance reached during the task. Coming to the mean speed on the paper. So here also above we had mean speed on the paper, and this is for the 19th task. And here we have number of pen down. It means the total number of times the written instrument was placed down on the paper, and it is for the 19th task. And here we have pressure mean. It is the pressure kept, it is the average pressure applied on the writing instrument while writing or drawing. And here we have total time for the 19th task. It is the 8 time for 22nd task. Here we have 8 time for the 23rd task. And here we have paper time. Paper time, it is for the 23rd task. Here we have total time for the 23rd task. And here we have total time for the 25th task. Now let's give input to all these parameters. So we have those inputs in the sample file, which are used as test cases. So let's open the sample file. So let's try using some of these test cases. So let's try with the first test case. So the total time is 9185. So copy it for it is for the ninth task. And here we have to give the GMRT on the paper. So it is 130. Mean speed on paper is 2.5. Paper time is 3945. and mean GMRT is 192. Total time for the 15th task is 36130, and A time is 9930. Mean jerk in the air is 0.5000. The next one is total time for the 17th task is 24740. Next, 8 time for the 19th task. Max extension. Next, it is mean speed on the paper for 19th task. Next, number of pen down. Pressure mean. Next, total time for the 19th task. A time for 22nd task. E time for 23rd task. Next, paper time for the 23rd task. Total time for 23rd task. Total time for 25th task. Now click on predict. So here we got the prediction that patient is healthy, he is not suffering from any Alzheimer's disease. So he is completely stable. He can remember all the things where he will not forget any things. By analyzing these handwriting parameters, here we got the outcome. So it is dependent on all these variables. So now let's give other set of inputs. So click on prediction. So here we have to give the total time. Let's take fourth test case. Not the fourth test case, let's take the 15th test case. So here I have given input to all these parameters. So now let's click on predict. Click on predict. Here we got the prediction that patient is not healthy, he is suffering from Alzheimer's disease. So based on the given handwriting values, here we got the prediction that patient is suffering with the Alzheimer's disease where he will be able to forget the things in the further. So it is better to take the treatment initially. So now let's try with the other test case. So click on prediction. Let's enter these values. So here I have given the input to all the parameters. Now we have to click on predict. So here we got the prediction that patient is not suffering with any Alzheimer's disease. That means he's completely healthy. So this is how we can execute the project, and we can check with all the test cases whether the person has Alzheimer's disease or not. So now let's check with the graphs for the ANOVA dataset. So click on ANOVA dataset. Here we'll be having graphs for all the features extracted with the ANOVA feature selection technique. So this is a sample outcome graph where on x-axis we have patients with the Alzheimer's disease and the healthy persons. So here on x-axis we have patients and healthy persons. On y-axis we have the count. So if we observe, almost they are equal, only we have little difference in that. So there is no class imbalance in it. Here we have correlation matrix. So this shows the correlation between independent variables. And here we have the accuracy graph. So here on x-axis we have accuracy score, and on y-axis we have all the algorithm names. And here all these algorithms are built after extracting the features from the dataset using ANOVA. So all these models are trained on the dataset which are where features are extracted to the ANOVA dataset. So if we observe, voting classifier is having the highest accuracy. And here we have the precision score comparison graph. This is the recall score, FN score, AUC score, and here we have Cohen Kappa score, MCC graph. Now let's check with the RFECV. So this is a sample outcome graph, and here we have correlation matrix. So this matrix shows the correlation between the variables. And here we have accuracy graph, where on x-axis we have accuracy score, and on y-axis we have algorithm names. And here all the algorithms, they are trained on the data set whose features are extracted with the RFE CV technique. And this is the precision score, this is the recall score, this is FN score, AUC, Kappa score, MCC. Now click on logout. In this way, by using machine learning techniques, we can successfully, we can efficiently detect the Alzheimer's disease and take the precautions early.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.